All right, let's start the meeting. As you know, this meeting is recorded and will be uploaded to public internet. So whatever you say is likely to remain for a very, very long time. With that, let's start talking about some of the items that we have. Unfortunately, we don't have that many participants in today's meeting, so some of the feature owners may not be present today. We can actually go to some of the items that we have and in the recording, so hopefully those people will get back to us later. One of the items for 115 is the new equivalence cache and new equivalence class. Hopefully we can get these to a level that is performant enough soon, and we can have those in 115. We definitely need to have a proper cap for these in order to merge them in 115. Cube batch is one of the other items, which is still in an incubator project. Klaus is taking care of that, and that is, as far as I know, and the latest, based on the latest updates, it's going forward pretty quickly. And yes, so there is another item which is basically building the scheduling framework and building the extension points for the scheduling framework. We have already the design merged, so the revision of the design is also merged. Jonathan actually helped us with refining the design, so that is in. I will probably start creating a few issues for building some of the smaller items or smaller extension points in the scheduler for the framework. We already have a couple of extension points based on the older design, the previous design. Those probably need to be modified slightly to make them fit better with the newer design. So I will probably, either myself or Jonathan, one of us will probably make those changes, and then we will create some other issues for other folks to contribute. Hopefully we can get a major portion of this in 115. We still would like to work on implementing pod scheduling policies. These are the policies that specify what kind of scheduling features people can put on their pods. That's another item. This is not going very well because there are so many different ideas about how to do it. And I've been working with the SIG auth, particularly with Tim Alclair, about designing this. I will probably keep doing that for the coming quarter. We may have an early version in 115. We will see. We still would like to build an integration test library for our benchmarks. That's something that we need help. Jonathan, you are here now. So do you know if you will be able to take care of this in 115?
That's a good question. I had started a branch with this benchmarking framework, and it kind of fell by the side of the road. So how many weeks do we have for 115?
Oh, 115, we probably have another 3 months-ish before code freeze. I would expect the code freeze to be, I don't know, no sooner than in the May or so.
If that's the case, I think there's a reasonable chance of getting that finished up. Yeah. I have some, I think, open design questions regarding.
We lost your voice. Okay, we don't hear you. But anyway, we can talk about this later, Jonathan. Looks like we lost your voice. So sure, we can actually discuss this later, and hopefully we can get this in as well. Yeah, so Wei, I know you're working on interpod affinity to support more than one pod. We hopefully will get that in. I know the PR is already out. Hopefully we can just address the remaining things in the implementation, and this should be good to go, right?
Yeah.
Okay. Sudesh, you are here. We are working on resource bin packing. I left some comments, and I saw that you answered some of those comments already with respect to basically modifying one of the existing priority functions instead of just creating a new one for resource bin packing. So hopefully, I mean, based on your comments, looks like you're fine with that design as well. So hopefully we can get that in 115 as well. Is that fine with you? Do you want to discuss it?
Yes, I think that works for me. So I just had some questions regarding the cap. Should I like give more design details in that, or that can be worked out after it's merged or something like that?
So for the cap, I don't, you know, it's really up to us. But given that those priority functions already exist, and we already pretty much know what we want to do, and the current cap it's sufficient in my opinion. So we can, I mean, the rest becomes implementation details rather than design, really.
Yeah.
So we can follow the rest on the PR.
Okay, thank you.
Yeah, sure. Supporting non-preempting priority. So I know that Valerie is now here. You've been working on this. You ran into an issue, I believe. Alex Wong, or no, not Alex. Yeah, Alex Wong, I believe. He actually managed to fork that and fix the issue with some of those tests failing with non-priority, and he managed to fix that issue. So hopefully we can get that in 115 as well. We might actually need a cap for this.
I think we do, yeah.
Yeah. So we don't have a cap right now, correct? If I'm not mistaken, we don't.
I don't think there is one. I think because it's such an old issue.
Yeah, exactly. So we need a cap. I don't know if you are willing to write one, or if you would want.
I can do that.
Okay, sounds great. So thank you so much for doing that. Then we can have this in 115 as well. We need more scheduling metrics. Wei has volunteered to take care of that. All right, and then there is one relatively large feature that we would like to add to the scheduler, and that's being aware of physical nodes in a cluster. So here the problem is that in many cases, people run Kubernetes on-prem, basically on physical hosts. And when they do so, they usually run Kubernetes on top of another virtualization layer. For example, they run vSphere, or they run KVM or something like that, and then create virtual machines. These virtual machines become their nodes of the cluster. So now imagine, you have, let's say, 3 physical hosts in your cluster, and each run, 10 virtual machines. So 10 nodes of the cluster land on a single physical machine. Kubernetes, and his way of spreading pods, just spreads pods among the nodes that it sees. The problem is that some of these nodes, or in some situations, many of these nodes, land on a single physical host. Now, let's say that you run a web server which has 10 replicas. It spreads these 10 replicas among 10 nodes, and those 10 nodes happen to be on the same physical host. So when the physical host goes down, all of those 10 replicas go down, and your web server or your web service will see an outage. This is not ideal. A lot of folks are running into this issue. This is not even limited to physical hosts or on-prem clusters. It kind of applies even to an extent to the cloud providers too, because they have the very similar setup. So it would be even more reliable. I mean, your Kubernetes cluster would be even more reliable if you could do the same thing for cloud providers. So we are planning to build something that allows Kubernetes to be aware of physical hosts, and then it labels nodes of the cluster with those physical hosts as well. So those physical hosts essentially become another failure domain label in Kubernetes, and Kubernetes starts spreading pods among those different failure domains with different physical hosts. We currently, as I said, have only a way to spread pods among nodes of the cluster. So with this, we were going to change our priority function to spread among physical hosts. If that is not possible, then it spreads among the nodes. For example, in case that there are not enough physical hosts, then we don't have any other option than spreading among other nodes in the cluster, which some of them could happen to be on the same physical host. So I have piled an issue for this. It's in our spreadsheet, and we would like to work on it. I believe this is Alex has already volunteered for doing this, but this is, I believe, is a more than one person project. We need more volunteers. So basically, there are multiple aspects to this. One is to build add a label for the failure domain and add the functionality to the scheduler to spread pods among physical hosts. That's one part of the project, which is probably one person project. But there is a much larger part of it, which is essentially building admission webhooks. That's one option. There could, you may come up with other options as well, and those might be even better. But one that I thought about is just building an admission webhook for various virtualization layers. For example, we could build one for vSphere, we could build one for AWS, we could build one for GCP, and so on. So what this does is that it communicates with some of these APIs. For example, with vSphere APIs, reads the physical host information from vSphere, and then adds a label at the time of node creation to the node with this label. For example, let's say we call it failure domain, I don't know, .case.io or whatever / physical host or something like that. So, and then that admission webhook is responsible for adding these labels. We need to build probably a few of these admission webhooks. We can start with vSphere for now. In the same issue, I commented that there is already a vSphere plugin that has this functionality. Actually, we can borrow ideas from there, or at least look at it for reference to what vSphere API we should call for finding physical hosts, and then build that admission webhook. So if any of you folks or other folks who are not here and will listen to our recording in the future are willing to participate, please go ahead and mention that in this issue. We can probably basically break the work among multiple folks to take care of different parts of it. And finally, Leon is going to work on supporting less than and greater than operators for interpod affinity. So the idea here is that currently our label selectors for affinity and anti-affinity support, I believe, equal, not equal, or in and not in operators. Basically, you can specify a set of operators, and you can say that you don't want the labels of the pod to be in this set or not to be in this set. But we also want to support less than and greater than operators so that people can specify a range of values and say that if the pod, for example, is in this range, then we have affinity to it or we have anti-affinity to it. So Leon is working on that. The KEP is out, and we need to implement this. One of the main concerns here is that affinity and anti-affinity is already slow. We have made it a lot faster than before, but in the past it was super slow. It was like 1,000 times slower than other predicates. It's now kind of bearably slow. It's like 10 times slower, but still significantly slower than other predicates. And by introducing this operator, we might make it even slower. So we definitely need to make sure that this is not going to impact us much in terms of performance. So that's one of the other than implementing the feature, it's one of the other items that we need to take care of, and we need to ensure performance is adequate. These are the items that I had in mind for 115. It's actually quite a bit. But if you have other items that you'd like to discuss or have any comments or feedback about the existing ones, please go ahead and share with us.
Maybe I can mention something on the event pod distribution feature.
Yes.
I think basically we are almost have a sort of agreement on the direction. And only confusing things is that whether we can or we cannot support the semantics I mentioned in the pod anti-affinity. According to my understanding, I prefer to leave it as is because it will make the design be confusing and vague in providing the even pod distribution function. So basically, I think after the offline talk with Bobby, I think the plan B, which is make the pod even distribution as a standalone predicate or priorities, makes more sense because it has more neat design and maybe less error prone and it's a standalone stuff. And basically my idea is that it can extract some existing fields in pod affinity to the even spread expression. So that means we have to implement similar things in pod affinity to make sure which pods should be grouped together. They are more attractive to each other to be placed together, right? And based on that, we should have a top level max skew settings to make sure the degree of imbalance, right? So whether they are totally perfect balanced or they are tolerant to have some degree of skew, sort of like that. And we can have should have a top level. We can also call it topology, or we can use a new name called distributed by or distribution key, so that it doesn't cause confusion with existing topology key. That means among this part we calculate to match together. We have a high-level distribution key to manage them evenly across the cluster and defined by the max skew. So I think it works. So it can work independently, right? But it can also work perfectly with, the node affinity and the pod affinity.
Right.
To some extent, it's kind of a little duplicated with pod affinity, especially when their definition, I mean, the pod selector, the namespace, the definition are exactly the same. They are kind of identical, but we are not enforce people to have the same definition in both the even pod spreading and the pod affinity, right? So it's good to have them both there if they want, right? So we don't enforce them. Right. Only issue is the pod anti-affinity because it works independently. So we are not enforced to change the semantics of current pod affinity, which is to run only one pod exclusively in a topology domain.
Yes. So thank you. Thank you for sharing this. I agree with many things that you said. One regarding by the way, first of all, I apologize. I didn't mention this in our plan for 115. It's actually one of the important projects that we would like to implement in 115. So the idea here is that we are gonna add a new feature to spread pods evenly among different failure domains. Basically, it's very similar to anti-affinity, but in anti-affinity, we were in like hard anti-affinity. We were letting only one pod to exist in a particular failure domain. For example, if the failure domain was a node, we were spreading pods among the nodes, and if more than one pod had to land on the same node and there was no other node in the cluster, then that pod wouldn't get scheduled. Right now, let's say that you have, for example, 10 replicas, you have 5 nodes. With this new feature, you evenly distribute these pods among these 5 nodes. So each pod gets, each node gets 2 pods. this is the idea behind evenly distributing pods among in a failure domain or among failure domains. Regarding the topology key or distribution key, I honestly prefer to go with the same topology key because it's essentially the same thing. It's the same concept as we have in anti-affinity, and I feel it makes more sense for our API to be consistent. But once this feature is built, I think we need to go back and change certain things in anti-affinity. That's what we had from the very beginning. That's basically was our plan from the very beginning. We may want to completely get rid of preferred anti-affinity. That is basically not needed anymore. Essentially, this even distribution or even spreading works exactly similarly to preferred anti-affinity. And we should probably make hard anti-affinity work only on nodes, not any other failure domain. That will improve performance of anti-affinity much and overall performance of the scheduler as well, because today, even if a pod doesn't use anti-affinity, we need to check anti-affinity to see if there is any other existing pod in the cluster that has anti-affinity, and that anti-affinity could get violated by the pod being scheduled. So anti-affinity is a little hard to check and takes a lot of cycles. If we make it limited to a node only, then it becomes a much simpler check. When we run predicates, we can just easily check whether there is any anti-affinity on any other pods with anti-affinity on a particular node. So basically, to summarize, we're going to build this even spreading of pods, and then we are going to next step after this is already there and this is stable enough. We are going to go back and start making changes to pod anti-affinity feature that we currently have.
Yeah, I think so. And my idea is more aggressive. I think in the future, maybe we can kind of deprecate the pod anti-affinity because the feature can be implemented using the even spread.
Yes.
Even pod spreading using max skew equals 1. Yeah.
Absolutely. One thing though is that when we deprecate, then we need to have a replacement for users. So if you say it's deprecated, but there is no replacement, then users will start asking what is the alternative to use. So we cannot start deprecating as soon as we start building this feature. We should probably have at least the first version ready.
Yeah, absolutely.
And then deprecate it.
Yeah.
Okay, these are all that I wanted to talk about. So we have 4 more minutes left in this meeting. If you have other questions, comments, please share with us. Okay. Looks like there's Jonathan, you want to say something?
I just had one comment, which is that the pod spreading, I definitely see like a lot of, like most of the users that wander into our Slack asking questions about the scheduler are basically asking for this feature. So I think it's going to be really valuable when we deliver it. I also think it supersedes maybe some of the other affinity changes that are in the pipeline, and I'm wondering if there's some sort of conflicting designs there.
Yes, so particularly this one addresses one other option, one other feature that we were targeting in the past, and that was supporting like max pods or something like that for anti-affinity. Basically, the idea there was that instead of having anti-affinity to only one pod, which is the current state, we could have another parameter in our anti-affinity API to say what is the maximum available, maximum acceptable number of pods that we have anti-affinity to. So instead of 1, we may say, okay, we can have like 3 pods in this failure domain, and after the 3, we no longer want to have any more pods in the failure domain. that option or that particular feature is no longer needed. Essentially, this even pod distribution or even pod spreading supersedes that, and we no longer need to build that max pod feature anymore.
Yeah, I think that feature, yeah, that's my origin design to sort of max pods on topology doing. But it sounds like a little tricky for users to configure or tune that kind of value, right? And
yeah, absolutely.
That's an absolute number. The absolute number, along with the change of your replicas, your deployment, well, it can change, and yeah, really tricky to figure out what's the right.
Yeah, especially when you think about auto scaling, the number of your replicas may change anytime, and it's very hard to know what that maximum value should be. So this even pod distribution is a much better design. Okay. Any other questions or comments? All right. Thank you, guys. See some of you folks next week. Bye.
Bye.